Hello and welcome. Week 6, problem 1. Portion of Nichrome. Ooh. That's awkwardly wonder what Nichrome is. Probably nickel chromium. Nichrome. Sounds almost like a supervillain name. I know elements. Used in resistance wire. Oh, nice. Applicable to real life. Alright. A portion of nichrome wire of radius 2.8 millimeters is to be used in winding a heating coil. Like a toaster, I imagine. If the coil must draw a current of 9.5 amps when a voltage of 120 volts is applied across its ends, find the following. Take the resistivity to be that. That's convenient they gave it to us. Alright, so I'm going to default here to Ohm's law. Find the resistance of the coil. So, we got V equals IR. Rearranging this guy. That's a terrible R. Up, arrow. Then we can have R equals V over I. That seem reasonable? Yeah, that seems good. Okay. So we know that voltage is what, 250? 120. That makes sense. So 120 divided by 9.5 equals 120 divided by 9.5. Ooh, that was a nice 5. Very round. Alright. That's going to be what, like 13? 120 divided by 9.5. We get computing, and oh, come on, Wolfram, you're not this slow in life. Internet, I blame you. Alright. 12.6. Okay, so it's 12.6 ohms. Okay, I'll go for that. Equals 12.6 ohms. Perfect. And it asks for ohms, not kilo ohms. So that's a good sign. It's a good sign. Boom. 12.6. All right. Next part. The length of wire you must use to wind the coil. All right. So here we're going to use resistivity. So we know that the resistivity of chrome is 1.25 times 10 to the negative 6. Alright. I'm going to write this guy down real quick. Whoop. Equals. Let's zoom in a little bit more. Resistivity equals 12.5 times 10 to the negative 6. There we go. Okay, now let's look at the units for this guy. I think I said ohms meter. There we go. Ohms meter. 1.5 times 10 negative 1.5. I did it. Okay. 1.5. So I'm going to redo this guy real quick. You and go away. So let's do 1.5 times 10 to the negative 6. There we go. And then we have ohms meter. Alright, so your first thought here is dimensional analysis, which is a good first thought, but it's not what we want here. So the formula that you're going to use for this guy is, let's see if I can look this guy up. Resistivity. So there's probably a definition for resistivity. Here we go. And this is the one we're going to look at here. Rho equals RA over L. So, I'll write that out, right out here. So, rho equals RA over L. So I'm going to rewrite this in a way that looks more logical. So, what we have then is resistance equals rho times L over A. So this is where I use the hydraulic analogy. So if you have water in a pipe, the water in a pipe is going to flow, and assume there's like filters and resistance, and it's not a perfect pipe, etc., etc. So the pipe, how much resistance to flow is going to have to do with how long your pipe is, so I'll call that length. The resistivity of the pipe, you know, how many filters per meter, whatever it is you want to say. and then the area of the pipe. So if you have a longer pipe, it's going to be more resistance, and if you have a skinnier pipe, it's going to be more resistance as well. So the idea here, the same idea goes for wires. So here, the resistance to the water flow would be, some constant associated with the pipe, and then how long the pipe is divided by how wide the pipe is. So the bigger your pipe, the easier water is going to flow through it. So we know at 2.8 millimeters wire. All right, so that's going to be, for analogy purposes, the radius of the pipe. So we want to know the length. I think they said length. The length of wire. So we're looking for L. So I'm going to rewrite this guy real quick. So we're going to have, so I guess this is the second time I've rewritten it. That's okay. L equals A R over rho. Or in this case, rho is the resistivity we just had. So A is pi r squared, because we are looking for the 2.8 area of the circle. We're assuming a circular wire. So we'll have times 2.8 times, and this will be squared, and it'll be 10 to the negative third squared, which becomes negative 6, because 10 to the negative third squared is 10 to the negative 6. R is resistance. Aha, that's answer from problem 1, which I think is just a normal number, like 12.6. Yeah, that's downright reasonable. Times 12 to the 6th. 12 times 12.6. And we got to divide it by the resistivity, which we said was 1.5 times 10 to the negative 6th, which was 1.5 times 10 to the negative 6th. Perfect. So here, get rid of that. There we go. 10 to the negative 6 cancels, and then we can just go straight calculate this. So pi times 2.8 squared. I could do it fancy like and actually use pi, or I use 2.1415, which I am. 2.8 times 2.8 squared times 12.6 divided by 1.5. Hopefully this will give us a number that's not in kilometers. 206. I'll say 207. So that actually seems reasonable. Yeah, that might actually be true. It might even be true. 207. Bam. The answer I'm going to give is 207. That's terrible 2, and that 7 needs help. There we go. What? No. You go away. Yep, and that is how you do problem 1. So the trick here is, just because you see the ohms meters here, your initial thought is dimensional analysis, but for this one you need to actually use a little bit of logic, and you can rationally think of how this formula is. If you're given like a formula sheet, you can look at this and be like, okay, that kind of sort of makes sense. So if not, you can just remember it. It's not that groundbreaking in life. You rearrange it, solve, and then you get the length. All right, perfect. On to problem number 2.